Hello everyone, welcome back. In the previous videos, we introduced the three pillars of Kubernetes observability: logs, trees, and metrics. We also talked about the benefits observability brings when monitoring and operating a Kubernetes cluster. And at the end, we reviewed how different Kubernetes components fit into different layers of the cluster. So in today's video, we are going to continue from there, and we will focusing on especially on the metrics. Well, when we break down the three pillars that construct the observability of the Kubernetes cluster, the metrics, trees, and logs, they each rely on different data types. And because the data types are different, so the technology, where the storage tools and the collector tools are also different too. And we know that the metrics are time series numeric data and also together with the timestamps. And so we usually use the Prometheus to these collectors to scratch them. And we use the TSDBs to store the metrics data and use the UI tools that with the name of the Grafana to visualize them through the dashboards, charts, and design some alerts based on that. And when it comes to the trees, and we know that the trees data types is organized by the request flows, and it is the structured object structure data, object structure span data that represents the request flows. We usually use the open telemetry collectors or the Jigger agent to collect the data sets that for the trees, and the collected data sets are stored in uh, to store it by the tools of the Jigger backend or Temple or NoSQL. NoSQL database is usually used to store the object data. And after the data are collected and stored in the NoSQL, we usually use the Jigger UI or Grafana to provide this the dashboard to visualize the data of the trees. And when it comes to the logs are usually the text-oriented data, and some of them are semi-structured. And the logs are collected usually by flinted or flintbit or log slash. The collected data are pushed or centralized to the tools that with the name of the Elasticsearch or Loki to provide it a more high efficiency query speed. And those tools are very good at querying, create index and querying to the text structured data. And there is a famous stack called ELK or EFK, or constructed by this kind of stuff. And they are focusing manipulating the logs data. And after the logs data are collected and stored in the Elasticsearch or Loki, and the Loki is compared to the Elasticsearch. It's more lightweight, do not so heavy as the Elasticsearch. And when the data are collected and stored in the storage layers, and we can use the Kibana or the Grafana to provide the visualizations and analyzing the data that stored in this layer. So after we go over all those three pillars, we can see that this is very similar to they just satisfy the same parting, that is the different data types and collect data and store the data and visualize the data. So they just follow the same parting, but because of the nature or the types of the data they collect are different, so the teach stack they use are a little bit different. The TSDB are designed very friendly for querying time range data sets in a very high speed, and the underlying algorithms are designed friendly to this kind of data size query and searching and inserting such kind of operatings. So now let's return to the metrics, and it is today's main topic. Well, a complete metrics pipeline usually contains three major parts. The first part is the metrics data collectors. And the matrix data storage layer, we use the Prometheus here. And the matrix data visualization tool, and we use the Grafana. And the visualization and analytics can this kind of services where features can be provided in the Grafana too. And you may see this pattern if you are familiar with the MVC. This pattern, especially in the areas of Spring Boot application, and you can take it transfer from the MVC pattern to the matrix observability this area very easily. You can just take that the Grafana is just like a UI front-end page, and the Prometheus like the controllers to provide a lot of complicated query conditions to query the data that's stored into the TSDB. And the TSDB also like the traditional databases, which is the RDBMS. And the traditional databases, RDBMS, the internal contained data are structured data site. So we usually use the standard circle query languages to fetch the data in a very high speed. And because of the TSDB stored data features is time series data. So they just the engineers of the Prometheus team just design another query languages that suits for the time series the data from the TSDB. They are just the same thing, but because the data type is different, so the query languages algorithms a little bit different. And when it comes to matrix collectors, you can just take it in the MVC parting as the data source streaming data. So the flow partings of the matrix is the collect, store, query, and display. Both the store and query are provided by Prometheus, and the collectors are coming from different in our current context because we are focusing on the Kubernetes component matrix collect, and the matrix collectors are distributed on the Kubernetes cluster, and we use the Kubernetes node exporter and also C advisor, and also let me think about it is KMS to help us extract different layers of the components of the Kubernetes component to consume the metrics. So here is the matrix storage data flow. And so from this slide, we can look at the whole matrix pipelines using the Prometheus and the Grafana. And on the left side, well, this diagram is not drawn by me, and it's drawn by this engineer. And I also leave these articles references at the end of this slide, so you can take a look at the blog written by this guy. I just copied the image and placed it in my own slide. And so on the left side of the diagram, originally it just showed the applications, exporter, and third-party applications. But in our current Kubernetes monitoring context, we can just replacing them. The left side is mapped directly to the Kubernetes all metrics producers, which are the upstream data source providers, and to light the Prometheus server to subscribe or pull the metrics data by the internal component in the Kubernetes server called the data retrieval worker. And when the data retrieval worker fetches the metrics data, and it will do some filtering and do some modifications and synchronize the metric data to the time series databases. The time series databases will synchronize the data from the memory and maybe doing some modifications and continue for filtering and write them down into the disk layer. And here we can also see it provided another, it just exposed a service that's just like we can use the prompt query languages to query the data that's stored inside of the TSDB. And the query the data can be consumed to two front end. The first front end is the Prometheus web UIs. We can do some analytics, and also we can do some second compute based on the raw data we just consume from the TSDB. And it can also be consumed by the Grafana web UI, which we can create some charts and create some dashboard to show the metrics data. And the alert manager, we will not deep dive into in these areas, but I have to mention it here. The alert manager will um, fetching, we're doing some jobs based on the TSDB status, and we can set some rules to monitoring some indicators that stored in the TSDB. And once the indicator modifies and maybe go out of the limit or too low, and it will trigger an event. And this event is called the alert. And the event will be subscribed by different kind of channels, just like email, Slack, and Discord, and other communication tools. So this is a complete data flow that describes how metrics work together with the Prometheus and Grafana, and also the Kubernetes components metrics collectors. So next, let's move on to the deployment scripts. And in this section, I will give you a brief overview of what's inside the scripts, and then we will run the scripts. And even though I know that a lot of, and what we need to do is trying to deploy the Kubernetes cluster on our MacBook with the help of this kind of tool. And also we wanted to deploy the matrix collectors components which introduced in previous slides, layer by layer. And this time we are trying to use the YAML files, not Helm. I know the Helm is very convenient and it can automatically resolve a lot of version conflict, and you do not pay attention to select by yourself. But I think to the beginners, it is very good chance to understand the internal of the components installations by using kubectl apply command and configure the YAML files by ourselves. And it is very good chance, especially for us, just the finished practice tasks to prepare for the CKA examinations. And when it comes to a higher level or more advanced topic, for example, if we want to install the cargo city or still, we can directly jump use the Helm. But because we are just the beginners in this area, so I highly suggest to write your YAML files and manifest implement by yourselves and get your own hands on to write the scripts by yourselves. And when you are familiar with in this area, and then you can totally use a Helm to install the components. And after we install and establish the Kubernetes cluster and deploy all the matrix collectors component, all the things are going right, and we will do some verifications to verify whether components work in a very healthy status, and check the metrics endpoint to check whether we can fetch some metric data from the exposed metrics endpoints, and do some validation jobs. So I think in the next video we will get our hands on in the installing the Kubernetes cluster and the metric clusters. So I think this is the end of our recording, and see you in the next video.